All right, thanks for the introduction, Luke. I was going to say my name's Murphy Randle, but you said it. So instead what I'll say is now I'm all self-conscious, Tessa. Thank you very much. My slides are all like dark and non-contrasty, so I really genuinely apologize if you have a hard time reading them, and I deserve whatever I get on Twitter, which you can tweet to me on Twitter, which is Sploding Socks. Now I know to read it out loud. Sploding Socks if you want to tweet on Twitter. I work at Day One. We make a journaling app, and I'm going to tell you some stories today about Day One and why ports are very important to us. I tried to make a pun in the talk title, and it didn't really work very well. So we have a more boring but descriptive title, The Importance of Ports, because they are very important to us at Day One. I also run the Elmtown podcast. If you're not listening to it, that might be a good place to go learn some stuff. Thank you. Thank you very much. I appreciate it. Without further ado, let's get started by telling a story. So, how this talk was born. This talk was born of my ignorance, as many things are, unfortunately. I was implementing some features at Day One, and we used a client-side database based on IndexedDB in the browser, which is a hard thing to say, surprisingly. But in any case, there is no wrapper available for Elm and IndexedDB that I'm aware of, or at least at the time. And so I had taken a deep dive into some native code. I went and got the native packages and figured out how to write, pretend I was Elm and write libraries that expose tasks and things. And I wrote a little wrapper for the database library that I was using so that I could use it from Elm. And this seemed great at first, except runtime errors kept happening because it turns out the compilers are actually useful, and I'm not that good at programming. And so, like, I wrote this library, and I kept getting in runtime errors, and it was a big pain to use and to write and to add new things. It was kind of full of cognitive dissonance for me. So on Slack, where many of us hang out, which is pretty cool, by the way, now, we're getting close to 10,000 Slack members in the Elm channel, if I'm not mistaken. So good job, everybody. Yes, so I mentioned this experience in Slack, and I kind of was like, oh yeah, well I should probably be using ports, but I'm not. I'm doing native code, but here's why ports would stink. And I outlined some of the things we're about to talk about in a second. And then thanks, Evan, wherever you are, for getting on and taking time again to help me out. He replied and said, I think the problem is that you're doing it all wrong in your mind. Okay? Which turns out to be Evan's answer a lot of the time, because it's true most of the time. So I listened to him, and I rethought about the problem, and I came up with a new way of thinking, which has really helped and has made me really appreciate ports instead of kind of accept them, right? So the result was I got rid of all that native handwritten code. I got rid of all those runtime exceptions, all the possibility of things going wrong and wonky weird. I made boatloads of money. I'm just kidding, I didn't. I just like those emoji. But the idea here is that Elm and JavaScript remain in separate worlds with separate concerns, and the compiler still helps me. Well, there are layers of protection that lie between the two. Ports are Elm's way of interacting with JavaScript, and they keep the type system in Elm honest, because they make sure that only the values that are what you assume they are can come in or go out from Elm. So by using ports and using in a design that we will talk about in a moment, scaling of the interaction between Elm and JavaScript became pretty simple, became pretty straightforward. And by scaling, I mean as soon as you want to do something more with JavaScript than what you used to do, that's scaling there between Elm and JavaScript. So you have the ability to, in a principled and predictable manner, say, I want to add something in JavaScript. I know how to do it. It'll be pretty simple. So to illustrate this, let's build something together, kind of, very quickly. And here's a little demo of it, okay? It's a pocket journal from 1880, because they had computers back then, evidently. So you can create an entry. It's a very simple thing. Create an entry. We can write stuff. Hello. And then that's also editing an entry right there. And then we can delete entries. So 3 actions. Create entries, edit them, delete them. The important thing also is that this is stored locally. So, oh, that was wrong. Locally. So I can reload the page, and it's still there. So this is interacting with IndexedDB in approximately the same way that I was when I ran into the problem. So let's do this. And Okay, yeah, users can create, edit, and delete entries. Those are our 3 actions. And we're going to need to use ports to do this. Ports look like this. I already mentioned that they're for interacting between Elm and JavaScript. This is what the API looks like. You can have an outgoing port for sending stuff out to JavaScript. You can take some type and it'll produce a command that you can hand to the runtime, which will follow the same normal Elm pattern and execute the command, etc. Then you can have an incoming port, which produces a subscription. Sends you give it a message tagger. You say, OK, well, when you get through this type that I'm expecting right here, I want you to produce this message and hand it to the runtime. So it'll give you a subscription that you can use. OK? So first attempt. Let's go ahead and make this thing together, and let's do it incorrectly the first time. Here's some code, right? This is the bad port example. Here's some code that we're going to use to implement this, the naive way that I first approached using ports, which I think is a pretty common way. I think I see a lot of people doing this. Okay, so we're going to have this API where we can create, edit, and update entries. Well, that means we should probably have an API for each of those calls. So let's make a port for each one. Okay, so I'll have not just one port, but 2, because I have, I'm going to request the thing, and then I want to get the response to see if it works. So already I end up with 6 ports. And for each of those, I have, a type that goes out, the entry that goes out. Maybe an entry comes back in when it's created. Maybe I get back a count of entries that are deleted. So I'm kind of trying to wrap this API. And then I also have to create a message tagger or a message type for the responses for each one of those incoming ports. So I add 3 messages to my app. And then, OK, I've got to handle each one of those. So I add 3 branches to my update function. And then I've got to listen to each one of them. So I add 3 subscriptions to my app. And then on the JavaScript side, I subscribe 3 times to those outgoing ports, and I react to them. And then when I'm done, I can go ahead and send messages back in to the incoming ports. But this doesn't really feel good. At least to me, this feels too busy and a little bit complex, a little bit scattered mentally. Oops, that was not what I meant to do. So adding one JavaScript operation. Let's say we wanted to add some new thing where we could turn an entry upside down or whatever, because we want to do things. And so we want to add that. We're going to have to add 2 new ports and potentially touch multiple files by going ahead and adding new messages for those ports and adding the new subscriptions and handling them in the update function, doing all of those things that could potentially be spread across multiple places. It's a little bbit fragmented mentally. But here's the biggest problem. The request-response thing that we just said, where we have 2 ports, where we ask for an entry to be created in one, and then we listen for the response to make sure it got created in the other, it doesn't really feel natural. It kind of feels bad. And why does that feel bad? Well, what if we get a response to a request we never sent? That shouldn't be able to happen. What if we get multiple responses to a request? That doesn't make sense either. What if a response comes through that isn't even connected to the request that we initially sent? What if I just get a response to a question I didn't ask, and how do I connect? How do I find the response, the question I asked, when I get a response to connect them up? It's very confusing mentally. So let's try to clear this up a little bit. I realized that the reason I thought this way is because I was carrying mental baggage from being a front-end engineer that was used to JavaScript as a service. We go back to that quote from the Elm Lane guide that I showed earlier. Treating JavaScript as a service in my mind meant treating JavaScript as a server and ports as HTTP requests and promises. So by saying as a service, I had this mental baggage that said, oh, I'm dealing with pretend server and HTTP and promises. And that produces some bad mental assumptions, OK? So let's strike those right now. Treating something as a service does not necessarily mean treating it as a server. And communicating over ports is not akin to HTTP requests and or promises. It's a very different model. And that model actually has a name. It's called the actor model. It's called, yeah, the actor model, which means that the interaction between Elm and JavaScript is modeled on a mature design pattern that's made for concurrent and fault-tolerant systems, and has been for many years. This is not a new thing, but this is also why that request-response port pair felt awkward, because this actor model is not a request-response model. It's information in and information out. It's a model that's based on being able to fire off and send information whenever and receive information whenever. Sort of like chatting in Slack. I assume that many of us use Slack, so I don't know if you knew that Elm and JavaScript also use Slack. They like to talk to each other. And in this case, for example, we can send a message out to JavaScript and get many back in. In this case, we might have something like a progress bar, right, where you say, I want to track the progress of a download, and you get multiple events back that are giving you progress. You might not get any messages back in. You might want to talk to JavaScript and only say, hey, go ahead and log these things. I don't care what happens. So you don't even listen to response messages. You might send out many messages and only get one back. Maybe JavaScript is in charge of debouncing your messages. Maybe it's in charge of collating requests. Maybe it's in charge of batching information and then doing batch processes. And then at some point in the future, it's like, all right, cool, I got all your requests, and here's the response. Maybe your messages are out of order. Maybe you ask for two things in a certain order, and maybe the responses come in completely unordered. Or maybe you ask for something and expect a response, but it may never come. There aren't guarantees. So this system is designed, oh, I always forget this one. Maybe you never send anything out, but you only get updates. Maybe you never have a request, but you do want information from JavaScript. So this is the actor model. This is about Elm is an actor, JavaScript is an actor. They talk to each other with messages, and there's no like request-response thing. Okay, so as soon as we get that in our minds, that helps quite a bit. This is good as soon as we change our mind a little bit. And just to show that this is not a weird new thing, there are many languages and frameworks that have done this for years. The oldest of which that I know that's popular and mainstream in my awareness is Erlang and Elixir, which, yeah, I like that. Yeah, good clapping. And I was talking to Evan about this, and he was saying, like, this is a pretty good system because, like, when you're on the phone, you don't really get, like, runtime errors on your phone. Like, 30 years ago. Like, okay, this has been happening for a while. Like, you do the rotating dial phone, and then it's not like, undefined is not a function. You're like, oh, shoot. I gotta hang up, right? So this is some pretty good stuff. Okay, web workers use this kind of API. Scala and Akka use this. You can do it in Python. You can do it in many other languages. And there's some cool background on this if you listen to Elmtown episode 13, where I ask Evan all kinds of dumb questions, and he answers them in a smart way. Okay? Cool, so let's do this. Let's go ahead and fix up our first attempt with a better second attempt. So here's the radical idea. Instead of one port for each one of our API requests or API elements, let's just have one port for everything. Everything, the entire app, only one port. And let's get away from the idea of wrapping a JavaScript API. So maybe we don't take the IndexedDB library that I use from JavaScript and try to make an Elm interface to it. Instead, let's design our own API for our application that encodes the communication between Elm and JavaScript in a way that makes sense for communication between Elm and JavaScript. And let's do one more thing. This isn't necessarily part of this pattern that I'm going to introduce, but this is more just kind of a good principle. In this case, we were running into some annoying state syncing problems because we had the entry state in Elm and the entry state in our IndexedDB, and we were sending back and forth little pieces of information and trying to keep these pieces of state in sync. Well, let's just go ahead and get rid of worrying about syncing that state, and let's say that JavaScript owns all of the entry state. So we're going to notify the database whenever changes happen, when someone deletes an entry or edits them, and every time in response to those things, we're going to get back a list of entries saying, this is how all your entries should look. So we're going to let JavaScript own all that stuff. This is part of treating it as a service. This is part of treating JavaScript as a black box. We trust that it's going to be able to take care of that state, and we're also going to trust that communication between Elm and JavaScript in the browser is fast enough to rely on getting that information back right away and updating the UI. So let's design a pattern for an API. Now, I want each API, let me see how to word this properly. Each of your applications will have its own API that's unique to the application that talks between JavaScript and Elm. This pattern we're going to introduce here is a pattern for creating one of those unique APIs for each one of your apps. And I came up with just whatever name, so I'm going to call it the outside info pattern, which is not outside in, outside info. Words are hard. Okay, so here's some code for the outside info pattern. And the idea here is you might copy this code and paste it into a file in your app and change it according to each one of your apps. But I will throw in the idea here that this seems ripe for tooling to me. This seems like probably a nice opportunity for code generation or something, but let's just do it by hand right now, okay? So we create 2 ports, an outgoing port and an ingoing port, which I'm going to call 1 port just because we said 1 port earlier, but that's really just a pair. An outgoing port where you send information out, and one where it comes in. And you'll see this thing here called generic outside data. That's a new type. This is a type that has a tag that's a string that you can switch on so you can identify the message you're sending out or getting in, and it's got JSON encoded data. So this is just a generic type that represents any information that could pass between JavaScript and Elm. And then we create specific types for the specific actions in each one of the worlds we want to deal with. In this case, info for the outside represents all of the information that Elm could ever send to JavaScript. And it's pretty easy to use because it's all right there in that one type. And we can get autocomplete if we're using our plugins and our editors, etc. Here's another type that represents all of the information that you could ever get into Elm from JavaScript from the outside. So the nice thing is you can come into this file and very quickly see all of the communication that can go in either direction. Now, here's a function that you can use to generate commands within your update function by passing that type that we saw before, info for outside. So in this case, if we want to create an entry, we can just call send info outside, create entry. And that will jump down into this case expression, and it will turn that create entry into a generic outside info piece of data and send it through the port. So you'll see that we've got some string matching here, and we're encoding a null because we don't have any data to send with this one. But in branches below, I don't even know if you can see it on the screen. If it's not accessible, I'm so sorry. But there's other encoding right there. And then here's another function for getting info from the outside. This is a little more complex, but this takes a tagger that when we get info for Elm, which is that other type we saw before, we can turn it into a message that I'll call the update function. Or if we aren't successful in understanding this message, if we get a message we don't understand, that we can't decode or that we haven't seen before, we can go ahead and notify the app of that as well. So right here, that's called the tagger and the on error in the parts that aren't highlighted. So we jump down, and here's a place where we match based on that string value that's coming in. We try to decode the data for what we expect. And if it works out, we go ahead and send that to the update function. And if it doesn't, we go ahead and react to it by using the error tagger as was provided before in the function signature. Now, in the JavaScript side of things, we only have to subscribe to the port once. This is all the communication that's coming from Elm. And we go ahead and branch based on that string tag, do the work that we have to do inside of there, and then when we're done, we go ahead and send that information back through the same single port, and we give it the string tag, and we give it the data encoded as it should be. So that's the whole pattern right there. It all fit in one file, and it made a lot of sense. You could read it from top to bottom and understand what was going on. But the points of it are 1 port, or a 2-port pair, an outgoing and an ingoing port. And when you have that 1 port, you design meaningful data structures that describe the API that can talk between JavaScript and Elm and send that data through the ports, utilizing data serialization on entry and on exit for type safety. There is no request response model here. Once again, it's just messages in and messages out. So why the actor model? We won't go into a ton of that here because we do on Elmtown, but once again, high concurrency, fault tolerance, these are all good things. They're words that are exciting. And surprise, we need concurrency in the world where we're doing user interfaces. That's kind of a concurrent world, right? We want the user to be able to click around and interact with the user interface while we're doing stuff in the background. In fact, we had a problem with that at day 1, where I was making the web application. We have users with a lot of journal data, and the model that I was using for this web application is a full sync model. So the user would log in, download their journal, and this could potentially be megabytes of text data, of journal data, all at once. And the user interface would completely lock up while that download was happening because I was doing it on the main thread. And in fact, sometimes the browser would say, oh, this page looks like it's running slowly. Do you want me to kill it? And it's not really a great thing to kill it in the middle of a sync. So we had to figure out a way to get past that. So we had all this JavaScript code that was doing heavy HTTP operations and database interactions. And so we looked up, well, how are we going to solve this problem, and realized that web workers were a good solution to that. But I kind of dreaded moving all that code from the sync stuff into the web worker, and then I was thinking, oh man, we're going to have to change all these APIs. We're going to have to change the way that Elm talks to it so that we can actually like reach into the web worker now. It's going to be a nightmare. But once we sat down to do it, it was done in a matter of minutes to hours, because both web workers and Elm ports are kind of based on this similar actor model idea. And simply enough, JavaScript on the main UI thread became a message broker instead of a worker. And that web worker got all of the job of HTTP requests and processing megabytes of data and interacting with the database. And those messages that were coming through ports to JavaScript, I just forwarded them right onto the web worker, and vice versa. So in a practically no time, in a very short time frame, we refactored and got concurrency in a fantastic way. And here's a quick demo. So this is the day one web UI as it stands right now. We've got a few journals in here, and I can go ahead into my photo journal, and you'll see these gray boxes. Those boxes are using custom elements which talk to the web worker using the actor model, and that web worker will look in the local cache to see if it has entries, and if it doesn't, it'll fetch them remotely. Same thing when I view an entry full screen. So there's the actor model at work right there, and you'll notice that it's quite responsive as I'm browsing around, and that's once again using cache or using HTTP. And now here's the real test. I can download a big journal, and while it's working, I can still click around, and in fact, I can still get images. Or I could even go and I could search for Elm, and oh look, there's an entry right at the top. Thanks elm-conf. So long story short, ports were a huge benefit for us, and I think they can be a huge benefit for you too, as long as we remember to think about them correctly and use the model with which they were intended when they were designed. And that's it. That's it for me. Thank you, everybody.